Himalayas, the majestic land of tall mountains and glaciers, is currently one of the world's most sensitive hotspots to global climate change. A new report suggests that at least a third of the Himalayan glaciers are expected to melt by the end of the century. A situation that is predicted to intensify in the coming years, with far-reaching consequences on availability of water, food, and energy. Now, a team of scientists are braving the odds to carry out research in these extreme conditions and jagged terrain to understand the impacts of climate change. The Earth's cryosphere is a critical component of the climate system. It stores about 75% of the world's fresh water in form of snow and ice, majority of which is in the polar regions.
Cryosphere regions are mainly Antarctic, Arctic and Himalaya. These are the regions mainly the cryospheric studies are focused because where the ice and snow are present there. So this controls the energy, Earth's energy budgets. That's why we are interested to study this.
A part of this cryosphere also exists in the Himalayan region, known as the Third Pole. The Himalayan mountain range, along with the Tibetan Plateau, is part of this cryospheric system and contains one of the world's largest glacial reserves outside the polar region. All the major Indian rivers owe their origin to thousands of glaciers in the Himalayan region. According to the latest glacier inventory, there are more than 10,000 glaciers in the Indian Himalayan region. With a warming earth and changing climate, there are scientific evidences of how these melting glaciers are affecting the regional as well as the global climate. In order to undertake a systematic and a long-term scientific investigation of the Himalayan glaciers, the National Center for Polar and Ocean Research, under the aegis of the Ministry of Earth Science, Government of India, has initiated the HICOM project.
HICOM is the acronym for the Himalayan Cryospheric Observations and Modeling. HICOM is a project initiative made by NCPOR to systematically study as well as model the Himalayan glaciers through studies across the Himalayan the mountain with the various glaciers studied by various institutions to understand the behavior of the glaciers as well as the contribution to rivers and how they are going to be affected in the future changes. Although NCPOR is the leading agency, there are several institutions like IITs, IISERs and central as well as state universities taking part in this major initiative that will contribute to significantly to better understanding of the Himalayan glaciers and the behavior in a changing global change scenario.
Every year, scientists from this institute embark on a Himalayan expedition to conduct field observations and monitoring of these glaciers. As a part of this initiative, the center has launched the glaciological studies on 6 benchmark glaciers of the Chandra Basin, part of the upper Indus Basin in the Lahore and Spiti district. Their journey starts from the mesmerizing hill town of Manali. Driving through highly undulating and treacherous terrain for over 4 hours to reach a place called Batal along the Manali-Kaza highway. From here, the team will need to trek for over an hour to reach the base camp station. In order to facilitate the research, the center has established a high-altitude research station, Himanch, at an altitude of 4,000 meters at a remote region in Lahul and Spiti district in Himachal Pradesh. The station was inaugurated on 9th of October 2016 and provides all the basic amenities to carry out preliminary research. A team of scientists is here today as a part of their ongoing glaciological observations and plan to visit few of the benchmark glaciers over the next couple of weeks.
It's day 1 today and we are heading to Sutri-Dhaka Glacier. It is around 25 square kilometers in area and 11 kilometers in length, and it is our benchmark glaciers. We are studying that glaciers very thoroughly. So we are starting our scientific activities first from Sutri-Dhaka Glacier.
To investigate this glacier, the team, along with the porters, will have to initially climb to an altitude of around 4,500 meters through a highly menacing terrain covered with rocks and boulders to reach the snout. And then trek another 6 kilometers on the glacial ice, covered with dust and debris to reach the advanced camp at an altitude of 5,000 meters. Spread across 25 square kilometers in area and with a length of 11 kilometers, the Sutri-Dhaka Glacier is an important valley glacier in the Chandra Basin that feed to Chandra River, a major tributary of the Chenab River in the upper Indus River system. Once at the camp, the team's primary objective is to undertake the glacier mass balance studies. These studies help to estimate the health of the glaciers and its changes through time. To understand this, the team over the years have installed a network of over 40 bamboo stakes throughout the Sutri-Dhaka Glacier.
So we drill deep down to 10 to 12 meter and we install the stakes depend on the melting rate of this location. So this location the almost melting rate is 5 to 6 meter per annum. So we try to install the stakes almost 10 to 12 meter because at least one time installation will continue for 2 years.
Each year, the team measures the glacier melting by using exposed stakes. The difference gives them an estimate of the ice melt over the last season. This data is correlated with other data set obtained by the Ice Penetrating Radar Survey, where the parameters obtained from the automatic weather stations installed close to the advanced campsite and also by measuring the rate of meltwater discharge at the mouth of the glaciers. The team also uses advanced techniques using differential GPS and terrestrial laser scanner to generate accurate digital elevation models. This helps to acquire high-quality surface elevation information of snow and ice cover over a large range and its changes throughout the year. While the team is busy carrying out the terrestrial laser scanner survey, one of the scientists scoops out mud from a cylindrical melt hole on the glacial surface called the criconites. These criconite holes play a significant role in the glacial ecosystem as they host several species of organisms like algae, bacteria, tardigrades, insects, and even ice worms. The next day, the team prepares to head to an altitude of 5,200 meters in the accumulation zone. Adhering to all the safety protocols, the team puts the harness and rope up themselves, as the journey ahead is laden with crevasses. Here, the team digs a pit to measure the depth and density of snow, giving them an estimate of the snow accumulation over the last season. This data, along with the stake measurement in the ablation zone, are used to calculate the mass loss or gain of this glacier. Over the last few years, the team has seen a negative trend, possibly indicating the effects of changing climate. After spending almost 4 days at the Sutri Dhaka Glacier, the team returns back to the base camp. Later in the evening, the scientists dedicate time to carry out chemical studies of collected water samples. The station has a lab that helps them to carry out preliminary assessments of the samples. During the last leg of this expedition, the team surveys the Gepang Ghat Glacier. Situated at an elevation of around 4,000 meters, the team has to walk through several steep climbs and valleys in an excruciating hike in order to reach the pro-glacial lake created by the Gepang Glacier's retreat and melt water feed. This glacial lake is extensively monitored by the NCPOR team, as it is a potential candidate for a glacial lake outburst flow, also called the GLOF event. The team, apart from carrying out the mass balance measurements, also uses the state-of-the-art terrestrial laser scanning techniques that helps them to generate a precise 3D model of the lake and the calving glacier front. Satellite-based studies indicate that over the last 4 decades, the volume of the lake has increased by over 20 times, in proportionate with the retreat of the glacier feeding it. Therefore, a proper monitoring and management of this glacial lake are essential to prevent calamities, considering its close proximity to civilization in the downstream. In order to get a holistic view of these glaciers, the scientists are also using high-resolution aerial photography techniques. The team is experimenting with a fixed-wing drone that is fitted with a camera that can photograph these glaciers at a high resolution. These initiatives would help the scientists create high-resolution digital elevation models and reach out to regions on the glacier that are not accessible by foot. The data generated over the last several years does indicate that almost all the glaciers in the Chandra Basin are retreating, showing a clear sign of warming climate. The Himalayan glaciers are extremely vulnerable to climate change and needs a long-term monitoring plan, as more than 1.2 billion people are directly or indirectly dependent on these glacial river systems for their sustenance and livelihood.